Okay, in this video we're going to work through some chapter review questions for financial maths or financial arithmetic. In question 1, Anthony earned $1,016 in simple interest when he invested this much for 9 months. The rate of simple interest was, okay, for simple interest we know we're going to have to use this equation I equals PRT over 100. And we've been given lots of info here. He earned $1,016 in simple interest, so that's the amount of interest that was earned, 1,016, and he invested this much, so that's the principal, so we can substitute that into the equation for P. The interest rate is what we need to work out, so we don't know R, and the amount of time was 9 months, and expressing that is in terms of years, it's 9 over 12. So there we've got an equation. All we need to do is to enter it into a calculator. Okay, so here you can see we've put in the solve function and then we've written out the equation, and all we need to do at the end is to put comma and then R to let the solve function know that that's what we want to solve for. When we do that we get R equals 6.84. R equals 6.84, and R is going to be a percentage. So there it is, answer C. In question 2 we've got an interest rate of 4.11% per annum. The sum of $634 was earned in simple interest over 2.5 years. The amount invested, so that's the principal that we need to find, is going to be what? Okay, so again, I equals PRT over 100. This time, we know I is 634, and we want to know P. We know R was 4.11, and we know T was 2.5. We'll put all that over 100 and solve it. Okay, so here's the equation. The amount of interest, the principal we don't know, the interest rate, time is 2.5 years, it's all over 100, and then we put a comma P to tell it we want to know P, and it tells us 6,170.32. Okay, and that corresponds to this first answer here, A. Okay, in question 3 it says the farm brand dozen eggs costs this much. With an inflation rate expected to average 3.5% over each of the next 4 years, the dozen eggs will then cost. Okay, so inflation happens according to simple interest, and for simple interest we know I equals PRT over 100. So straight away we can put in the amount of interest, or the increase in the value, will be I equals, the principal was 2.4, the interest rate was 3.5, the inflation rate in this case, and the amount of time was 4 years. Okay, so we can work out the increase in the value of these eggs that cost $2.4 now. That'll be I. Let's work out what that is. Okay, so here's the equation that we put into the calculator. We didn't need to put the solve function because we were trying to find the thing that's on the other side of the equation, the I equals bit, so it's all set up. And we got 0.33 was the amount of interest, or the increase in the value of the principal. So 0.336. Now that gets added on top of this. That's the increase in the value. So if we add 2.4 to that, we'll get 2.736, which we can round to 2.74. That's going to be the value of the eggs after 4 years. And we can see that that's very close to this one here, D. Yeah, I guess they've rounded it up to 2.75 because, you know, it needs to be a multiple of 5 cents because that's the smallest amount of money you can have. So you can't have 2.74 as the value of something. Alright, let's move on to question 4. Okay, in question 4, which says we've got an investment of $12,000 at 6.15% compounded quarterly to reach $15,000, and we've got to work out how long it will take. Okay, so in question 4, we need to use the compound interest calculator, and we've been told the interest rate is 6.15, the initial investment or principal was $12,000. We've got to make the future value negative, because that's the way the calculator likes it, and put in 15,000 that was told to us, and it's compounded quarterly, so these are both got to be 4. And then we calculate n, and we find out that it's 14.62. Now note that this is not the number of years, it's the number of installment periods, or it probably would be better if it said the number of compounding periods. Okay, so compounding periods 14.62. Now, if it was compounded quarterly, then that means there's going to be 4 compounding periods per year. So if we want to turn this into years, we'll divide it by 4. There's 4 compounding periods per year. And then we'll have the number of years. So if we put in that number there and then divide it by 4, we get 3.65. 3.65, and since we have to make it a whole number, we'll round it up to 4 years. So the best answer is B. It'll take 4 years to turn that amount into that amount. Okay, in question 5 it says a sum of $5,000 is invested for 2 years at this rate and it's compounded quarterly. The value of the interest at the end of the term will be what? Okay, so this is compound interest again. We'll use our compound interest calculator. So we're investing it for 2 years and it's compounding quarterly. So the number of compounding periods will be 2 times 4. And the interest rate is 4.75. The present value is 5,000. That's always 0. And the future value is what we're trying to calculate. And this is already set to 4 times per year, which is what we want for compounding quarterly. So we've just got to calculate FV, and it says it's going to be $5,495. So that's going to be the future value. And the question actually asks, what's the value of the interest at the end of the term? So this is what the new value, the total value of the investment is, interest plus principal, but we're only interested in the 495 bit. So the answer is going to be A. Okay, we've got, it says that our current household income is this much per annum and grows at the rate of 6% per annum. With this rate being constant, the number of years required for the household income to reach this amount is... Okay, in question 6 it says the current household income is this much and it grows at 6% per annum. With this rate being constant, the number of years required for the household income to reach this will be what? Now, it really would be helpful if the question said whether it was simple or compound interest, but since it doesn't, we're going to have to try both and see which one gives us the right answer. Okay, let's try the compound interest one first. If we put in these values into the compound interest calculator, N we don't know, I is 6%, PV is 61,800, and the future value is negative 100,000. And we've got to make PY and CY both 1 because it doesn't say compounding periods other than yearly, so we'll just make it yearly. And then when we calculate N, we get this value here, 8.25 years. Now, since we need to get up to 100,000, after 8 years, it's not going to get us there. So we're going to need a 9th year. That's this extra 0.25, but it's only part of the 9th year, but we have to round up. We have to round it up. We can't round it down because 8 years won't get us to 100,000. So we have to round it up to 9 years, which would suggest it's that one. The other way to calculate this would be to do 100,000 the other simple interest way would be to do 100,000 minus 61,800, which gives us the amount of interest, or the amount of increase, is 38,200. And if we put that into the calculator, if we change that to 38,200 and then calculate for simple interest, then we get 10.3 years, which if you round it up would give us 11. Okay, so really the question should say whether it's simple or compound interest, because otherwise there's no way to determine which one the correct answer is. But it's actually compound interest is the right one in this case. They really should have put that in the question though. Okay, in question 7, it says that Ben has a store credit card with an outstanding balance of $850. If the interest rate is 24%, calculate the amount Ben will be charged if the balance is not paid by the due date. Okay, so with credit cards, they operate according to the simple interest formula. So I equals PRT over 100. We want to work out how much interest he's going to have to pay on this debt, on this outstanding balance. So the interest he'll have to pay will be 850, the principal, times the interest rate of 24%, and this is happening within a month, because credit cards, they operate on a month-to-month basis. So 1 month is 1 over 12 years. We'll put all that over 100. Okay, so here is the equation. I haven't put it inside the solve function because we're finding I, which is the bit over the other side of the equation. The computer's automatically going to calculate I for us. Don't need the solve function. And it turns out that I is 17. Okay, so that's the interest that's going to get added on top of this balance here. Now, when we look at the possible answers here, we see that none of them are $17, and on top of that, none of them are this plus this. The new balance would be 850 plus 17 would be $867. That's the new outstanding balance if not paid by the end of the month. Since none of these answers are here, it suggests to me that there's something that's been left out of this question. Possibly there was some more information they were supposed to provide, and they haven't done so. It may be the time that the due date is, which might be more than 1 month, it might be several months down the track, but it seems that they've left something out here which means that it's not possible to work out what the correct answer is supposed to be. So we'll just move on to the next question. Okay, in question 8 it says an electrical store offers its customers an 8% discount if goods are fully paid for in cash on the day. So we need to work out how much will Carly pay for a mini DVD camcorder with this marked price if she pays in cash. So she's going to pay $7.99 minus the discount, and the discount is going to be 8% of the marked price. So 8% times $7.99. So we just need to put that into a calculator and we'll get the discounted price. So $7.99 minus, and we'll put this bit in brackets, 8%, if we convert it to a decimal, is 0.08. So it's just 8 divided by 100, and then multiply that by $7.99, close the brackets, and we get $7.35 and 8 cents. Okay, so that's going to be the discounted price if we pay in cash. Answer B. In question 9 it says that a hire purchase agreement on a loan of $3,000 requires 24 monthly payments. The effective annual interest rate is 17%, so we need to work out the interest paid in dollars. Okay, now we know that from in the textbook it tells us that one of the equations for real or effective interest rate is 2400 times I, which is the amount of interest paid, divided by, on the bottom we've got P, principal, times the number of months plus 1. Okay, so we've chosen this equation because we know we're being asked about the effective annual interest rate, or that the question involves the effective interest rate. So we need to find an equation that involves that, and there's two options, and this is the equation. Of those two equations, this one involves the interest. The other equation doesn't have the amount of interest, as part of the equation, so that one's not going to help us to find out this quantity. Alright, so now we know we're using this equation. Let's put in some values. So we know R effective is 17%. 2,400 times I, that's what we don't know, so we'll leave I as that. And then on the bottom we've got P, which is the principal, and since there was no deposit paid, the principal is just the initial amount that was loaned, $3,000, and then in brackets we've got to put M plus 1. The number of months is 24, and let's add 1 to it, so 25. Let's put that into the calculator and solve it. So if we go Action, Advanced, Solve, and then put in our equation 17 equals, let's make a fraction, 2,400 times I, and then on the bottom 3,000 times 25, and then comma I, close the bracket. Okay, we get I equals 531.25. So that's the amount of interest that's going to have to be paid, and there it is there, answer E. Okay, in question 10 it says a new cooktop that's worth $935 is bought under hire purchase with a deposit of $100 and 18 monthly installments of $50, and we need to find the flat rate of interest. Okay, first, before we can work out the flat rate of interest, let's ask how much are we actually paying for this cooktop that's worth $935. Okay, that was the sort of purchase price, or the upfront price was $935, but we're going to pay a bit extra on top of that. Okay, because we're not paying for it up front, we have to pay a bit extra. How much are we going to pay? We're going to pay $100 up front, and then we're going to add 18 monthly installments of $50. Okay, and that adds up to 100 plus this is 900 is $1,000 altogether. So we're actually going to pay $1,000 instead of $935. Okay, so we can ask ourselves the question, what's the gap between this and that? How much of a difference is there? Well, 1,000 minus 935, the gap is $65. Okay, this $65, that represents the interest. That represents the extra money that we're paying as a penalty for not paying up front. So this is our interest. Now, for flat rate of interest operates according to simple interest, the simple interest formula. So I equals PRT over 100. So we can use that formula to work this out. We know the amount of interest is 65, so we can put 65 in there. And then we know the principal, the initial amount of the loan was $3,000. Sorry, it was $935. That was the original amount owed. But when we started off, we immediately paid off $100 of this loan. So we have to take away that 100 from the 935 from the principal. So it's really only 835 the principal. Okay, R is what we're trying to work out here, and T is the amount of time, which is 18 months or 1.5 years. So I'm running out of room here, so I'll just put 1.5 that needs to go in there, and then we divide all that by 100. Alright, let's put it into the calculator and solve. So this is another solve function, and this time the amount of interest is 65, and that equals 835 times the interest rate we don't know, and the amount of time is 1.5, it's all over 100, comma R is what we want to know. Let's solve for R. R is 5.19. 5.19%. And that is this answer here, D. Okay, so the key things to take from that, we knew we were trying to find the flat rate of interest. Okay, so we know it's going to be a simple interest kind of problem, and we know that we're paying this amount here for the goods, although this was the sort of initial price. So we know we're paying a bit extra, we're paying a bit of interest. Once we know the amount of interest, we can put that into our formula, and the principal is going to be the initial cost minus whatever deposit we pay. Sometimes you don't pay a deposit, so the initial cost and the principal are the same. R we didn't know, and time was 1.5 years given from that. Okay, next question. Alright, a laser printer is purchased for $790. It has an expected lifetime of 6 years and 0 residual or scrap value. Okay, at the end of its life, it's worth nothing. The amount of depreciation to be allowed per year in dollars, assuming flat rate depreciation, is what? Okay, so it started off at $790. That was its purchase price, its original price. And then if you minus the depreciation away from that, then you get the scrap value or current value. Okay, and we know the scrap value was $0. At the end of its life, it's worth $0. The purchase price was $790. So how much was depreciation to get down to 0? Well, that had to be $790 as well. Okay, so now we know that D equals $790. From this equation, purchase price minus depreciation equals the current value. Okay, now if we know that this is flat rate depreciation, which operates according to D equals PRT over 100, and we know our value for D, we can put that into the equation, and then we can put in all the other bits that we know. P is 790, R we don't know, so let's leave R as that for the moment. And the amount of time, well, to get from 790 down to 0, it took 6 years, so we can put 6 in there. Okay, and obviously this is going to allow us to solve for R, which isn't actually what we want, but it's probably going to be helpful, so let's do it. So let's solve for 790 equals 790 times R times 1 times 6, and put it all over 100. We want to know R. We get R is 16.67%. Okay, now that we know the amount of, the rate of depreciation, 16.67%, we can work out the amount of depreciation per year, the amount that happens every year. It's going to be 16.67% for 1 year, so depreciation equals 790 times R is 16.67%, and the amount of time is 1 year. We're only interested in how much happens in 1 year. Let's put all that in. So this time we can make R equal 16.67%. The time is 1, and we want to calculate how much D is. Okay, we get D is 131.70. That's the amount of depreciation that would occur in 1 year. Okay, we've got a slight difference. That's 0.67, this is 0.70. That's probably because we rounded this number here off. Okay, next question. Alright, we've got equipment that's worth $18,600, and it depreciates at 12.5% constant depreciation. In other words, flat rate depreciation. Its scrap value is 0, so we want to know the book value of the equipment after 5 years. Alright, so if we want to work out the book value, that's going to be the purchase price minus the depreciation. We were told the book value at the end of its life was 0, and it was originally 18,600. So how much depreciation was needed to get down to 0? Well, obviously all of it. So D equals 18,600. Now that D equals 18,600, that's at the end of its life when it's reached this zero scrap value. But then straight away in the question, it tells us that we want the book value after 5 years. So we're not necessarily interested in the scrap value, or the value at the end of its life. Okay, so this appears to be a bit of a red herring, this zero scrap value. We just need to know the book value after 5 years. Okay, to work out the book value, we need to know the purchase price, which we've got, and we need to know the amount of depreciation. And we've got everything we need to know to work out the depreciation. We've got D equals PRT over 100, because it's constant depreciation. P equals 18,600. R equals 12.5, we're told that. And the amount of time is 5 years. We're interested in the value after 5 years. So we've got everything we need to work out the depreciation, which we can then substitute into here, along with the P, and get the book value. Okay, when we put that into a calculator, we get 18,600 times 12.5 times 5 equals that, divided by 100 is 11,625. So 11,625, that's our depreciation. To find the book value, V equals 18,600, the purchase price, minus 11,625. And if we put that into a calculator, then we will get $6,975. So that's going to be our book value after 5 years. There it is, B. Alright, in question 13, a new computer costs this much. If depreciation is 33% per annum, reducing balance, the computer's book value at the end of 5 years will be close to. Okay, so for reducing balance problems, we use this equation. V equals P, inside the brackets, 1 minus R over 100 to the power of N. And that's actually what we want, is the book value. So this equation is going to take us straight to the answer. We just need to put in our values for P, R and N. Let's write out the equation. Solve equal V equals P is 3490. 1 minus R is 33. We'll put that as a fraction though, because it's going to be 33 over 100, and we'll put it all to the power of N, and N we're told is 5 at the end of 5 years. And then we tell it we're concentrating on V, close the bracket. We get V equals $471. And there's that answer A. Okay, question 14. We've got a piece of equipment worth this much. It diminishes at a rate of this much, or this percent. The owner decides to replace the equipment when its book value falls below $5,000. The time passing before the next replacement is required is close to. Okay, now it doesn't tell us in this case if it's reducing balance or flat rate. I'm going to guess that it's reducing balance, because we've done a lot of flat rate problems and the last one was reducing balance. This one probably is too. It really should say though. Alright, let's assume it's reducing balance. So V equals P 1 minus R over 100 to the power of N. We're trying to find N, that's unknown. The book value is $5,000. We want to know how long it's going to take to get to that book value. The P was 49,600. 1 minus R is 14.5, and that's over 100. And then we don't know. Let's put that into the calculator. We use the old one that we had up here. V is 5,000. This is 49,600. This is 14.5. And N is our unknown. Okay, we get N equals 14.65. Okay, now the question is, do we go to 14 years or 15 years? And the answer is that it takes exactly this long to get, for the value to drop down to 5,000, for the value to get to 5,000. If we round this down to 14 years, then, which we're obviously not going to do because it's closer to 15, but let's say it was a little bit closer to 14, we couldn't round it down then, because 14 years would not get us down to $5,000. Okay, we would have to round this up. We're not rounding it up because it's closer to 15, but we're rounding it up because 15 is the minimum whole number of years we need to get down to this value. 14 would not get us there. So it's not about which one it's closer to, it's about which one will get us to 5,000. Only 15 years time will get us down to 5,000. In fact, it'll go below, but we have to get at least there, not part way there, which is what 14 years would do. So it's got to be 15 years. Okay, in this question we've got unit cost depreciation, which we know is a little bit different to other forms of depreciation. And that's for a machine that costs this much with a scrap value of $750, and it's designed for this many hours of operation. Okay, so the depreciation that's occurred, depreciation equals the purchase price minus the current value equals the purchase price minus the depreciation. So the current value was $750, the purchase price was $11,340, and we can use this equation to work out what D must have been. So if we solve 750 equals 11,340 minus D, and tell it we're solving for D, we get D equals 10,590. Okay, so that's the amount of depreciation that has occurred. And then if we divide the amount of depreciation by the number of jobs that it did, or operations that it did 48,000 hours of operation. Divide that by 48,000, then we will get the unit cost depreciation, okay, which is a very small number it seems. 0.22 dollars per hour. Okay, so every hour it loses this much value. That's the unit cost depreciation. And clearly that's closest to this one, C. Right, in question 16 it says a company car purchased for this amount and depreciating at an average rate of this amount of money per kilometre has travelled this many kilometres in its first year and this many in its second year. In its third year, its book value will be what? Okay, so its initial value is 28,500 minus the depreciation in year 1 and then minus the depreciation in year 2. Okay, so we've got to work out how much depreciation occurred in year 1 and how much in year 2. Okay, we know that depreciation occurs at 47.4 cents per kilometre. Okay, so in the first year when it travelled 23,600 kilometres, for every kilometre it lost this much value in cents. Let's multiply that by the number of kilometres, and we'll do the same thing for this one, except this in the second year was 2,400 times 47.4. And we'll take all of that away from our initial value. Let's bear in mind though that we've got this in cents at the moment. We really should have it in dollars. So we'll change that to dollars when we put it in the calculator. So 47.4 cents in dollars, it's going to be 0.474, and it gets multiplied by 23,600. Put that in brackets, and we should have put at the start 28,500. That was our principal. So minus that in the first year, and then in the second year we've got to take away 0.474 times 2,400 kilometres in the second year. And after you've taken away all that value, you get 7,644 left. Okay, so that's the remaining value of the car after those 2 years. So in its third year, that's the value. Okay, these questions, the next few questions are short response questions, so they're not multiple choice anymore. They're just got to give a short answer to it. In question 1 it says an investment in BT bonds of this amount over 3.5 years earned Rebecca the same amount as 21,600 invested at this interest rate in a term deposit for 5 years. We need to calculate the interest rate offered by BT bonds. Okay, now again this question doesn't specify whether it's simple interest or compound interest. So given the absence of any other information, I think we'll just assume that it's simple interest. Okay, so simple interest is I equals PRT over 100. Now we need to work out, for the first one we don't know, we know the principal and the amount of time, we don't know the interest rate. That's what we need to work out for the first one. For the second one we know everything. We know the principal, the interest rate and the amount of time. So we've got two things going on here. Interest equals PRT over 100 for the second one. We know 21,600 is the principal, the interest rate 7.5 and the time is 5 years, and we can work out what I is going to be. Okay, and they tell us that this investment here, this one here, earned the same amount as this investment over here did. Okay, so once we've worked out what I is over here, we can transplant that over here and that's going to help us. Alright, let's work out, we've got to put all that over 100. So let's do that. 21,600 times 7.5 times 5, and then divide it by 100, we get 8,100. So the interest over here is 8,100. So that's the same as the interest over here, we were told. And over here we know the principal was 18,000. The interest rate we didn't know, and the amount of time was 3.5 years, and it's all over 100. So we can solve for R now that we've got everything else. Let's put in a fraction, 18,000 times R times 3.5, put it all over 100, and go comma R. We've got R equals 12.86. So that's our answer for question 1, 12.86%. Okay, in question 2 it says find the simple interest on $2,900 for 8 months at 5.8% per annum. So that one's going to be easy. For A, it's just going to be I equals PRT over 100. We'll put in our values, 2,900 times 5.85 times 8 months is 8 over 12, divided by 100. So 2,900 times 5.85 times 8, put this in brackets, 8 over 12, and divided by 100, we get 113.1. So that's the simple interest. In part B we need to find the annual rate of simple interest. So it's going to be a simple interest problem again. This time we're probably going to know what I is though, because we're finding the rate of interest R. So our principal was 1,600. That's P is 1,600. The interest rate is what we don't know. The amount of time is 3 years. It's all over 100. And the amount that it becomes is 2,000. So 1,600 will become 2,000. But we have to put in the amount of interest, not what the investment will become. This is the total amount, interest plus principal. We just want to put the interest in, which is 2,000 minus 1,600. That's the interest. So we want to put in 400 here. Okay, when we put that in the calculator and solve, we'll see what we get. 400 equals, make a fraction, 1600 times r times 3 and comma r is 8.33, and that's a percentage. Okay, in part C we need to work out the number of years over which 5,000 will amount to 6,000 at 6.5% simple interest. So note again, this is not the amount of interest, this is the total investment at the end. We'll need to adjust things a little bit. So I equals PRT over 100 again because it's simple interest. Okay, now this time we're trying to work out T, the number of years. That's what we don't know. So we should be able to put everything else in. We should be able to put I in. We'll come back to I in a minute. The principal was 5,000. The interest rate was 6.5, and T we don't know. It's all over 100. Now for I, the interest, it's going to be how much we've added on from the initial investment to get to this amount. So it's going to be 6,000 minus 5,000 equals 1,000. Okay, that's just coming from the total amount of the investment equals the principal plus the interest. Okay, if this is the principal here, and we're trying to find A, if we rearrange this equation to get I on its own, minus I, we've got A minus I equals P, minus A, we get minus I equals P minus A, and then divide, we want to get just I on its own, we don't want the minus, so divide by -1, and that cancels out the -1 there, and then do the same over here, and we get, this makes a positive A, so we get A, and this makes P negative, so we get A minus P equals I. Okay, that's why we did 6,000, the total amount was A, minus the principal, which was 5,000, and we got I, the amount of interest. Okay, let's put this I into here, and then we can solve that in the calculator. So solve 1,000 equals 5,000 times 6.5 times T over 100, and comma T is 3.08. And generally we like to give answers in terms of years and months, so 3 years is okay, but the 0.08 we need to turn into months by multiplying it by 12, and we get 0.96, which is 1 month. Okay, so 3 years and 1 month. Finally, part D. The sum invested at 8% per annum simple interest if it amounted to $4,000 after 4 years. So the sum invested, we're trying to find P. I equals PRT over 100. Our I is going to be the difference between 4,000 and the principal, which we don't know yet. So let's leave I for the moment. Okay, the principal we don't know. The interest rate is 8%, and the amount of time is 4 years, and it's all over 100. Okay, and let's put I over here. I we don't actually know just yet. If we work this out as best we can at the moment, so I equals P times 8 times 4 is 32P over 100. Okay, and then let's rearrange this because we don't know I and we don't know P. We can't do much more at this stage, but we know the other equation that we've got is the total amount equals the principal plus the investment I, and we know what A is. A is 4,000, so we might be able to put we might be able to rearrange this and put it into here. So let's go 4,000 equals P, we don't know, that's what we're trying to find out, plus I, and I is 32P over 100. Okay, so this is good now. We've got rid of one of the variables here. We got rid of the I and replaced it with another p. So now we've only got one variable, one unknown p, and we can solve for that using the calculator. So let's put that in. Solve 4,000 equals p plus, make a fraction, 32 times p over 100. We want to solve for p. P's $3,030.30. Okay, this question we've got $1,100 that's been borrowed from a credit union at the interest rate of 8.55% per annum. Karen repaid the loan in a lump sum when the principal and interest amounted to $1,400. How long to the nearest year did she keep the money? Okay, so she originally borrowed $1,100, and once it turned into $1,400, then she paid it all back. Okay, so obviously there's been a gain of $300 in that time. That's the amount of interest that that was added on to the original debt to get to $1,400. And we can see that in this equation here. So if that was the amount of interest, then we should be able to work out the amount of time that it took for that to happen, t, because we already know r and we know p. So let's put it all into an equation. 300 equals 1,100 was the principal, 8.55 was the interest rate, t we don't know, and it's all over 100. Let's put this into a calculator. So we want to solve. 300 equals 1,100. Now let's put it into a fraction. So 1,100 times 8.55 times t, and it's all over 100. Okay, so we've just got to add in the t and close the bracket. We get t equals 3.19. Okay, and we want to put this to the nearest year. How long did she keep the money? Now normally, if we're working out the answer to the nearest year, I'd say we'd need to round this up rather than down, even though it's closer to 3 than 4. Because if we round down, then it takes us to an amount of time that doesn't get us to $1,400. And that's typically the way we should think about these sorts of questions. But in the back of the book answers, it says 3 years. So either they haven't taken that into account, or maybe they just don't care. So they've said 3 years. I would have said 4 years to be on the safe side, because 3 years doesn't get us to 1,400. Okay, next question. Okay, in question 4, we've got a series of investments, and we have to work out how much money we end up with for each investment, and then compare the results with question 2, where we had flat interest investments. So these investments are compound interest investments. We're going to compare them. Okay, and the first one, we've got an amount owing of 2,900. So P is 2,900. The amount of time is 8 months, or in other words, 8/12 of a year. And the interest rate R is 5.85%. Okay, let's work these out using the financial interest solver. Compound interest solver on the calculator. So we'll go to financial compound interest. Okay, now this is being compounded daily for 8 months. So the number of compounding periods we need to put in here if we average it out, let's say 30 days a month for 8 months, we're going to get this many compounding periods, 240. If we wanted to do it a bit more precisely, I guess we could do 8 divided by 12. That's the fraction of a year that we're dealing with, and then multiply that by 365 days in the year, and we get 243 days, so slightly more. That's going to give us a more accurate answer. Okay, our interest rate is 5.85%. The present value is 2,900, that's 0. And the number of installment periods per year, we're compounding daily, so it's 365. And we want to calculate FV, so let's click on the FV button. We get $3,015.32. Okay, and if we take away that amount, which is the total amount, principal plus interest, take away the principal from that, so we just know the amount of interest, we'd have $115.32. That would be I, the amount of interest. Okay, in part B, we've got an annual interest rate of compound interest, so that $1,600 will amount to $2,000 after 3 years. So in this one, we've got to turn 1,600, that's our P, into the total amount, interest plus principal, of 2,000, and we've got to do it in 3 years. And we're looking for the annual rate of compound interest, so compounding periods are 1 per year. Let's put all that into our compound interest solver. So the number of compounding periods in 3 years, there'll be 3 of them, 1 per year for 3 years. The annual rate of interest is what we're trying to find. The present value is 1,600. The future value, we've got to put a negative in front of it, will be 2,000, and we're compounding once per year. So when we do all that, we can solve for the interest rate. 7.72%. Okay, for part C, we've got the number of years over which $5,000 will become $6,000 at 6.5% per annum compounded quarterly. Okay, so our P is 5,000, our total amount is 6,000, that's our future value. The interest rate is 6.5%, and we're compounding quarterly. Okay, so N is what we're trying to find here. We don't know that. We know this is 6.5, we know the present value is 5,000, and we know the future value is negative 6,000. And we're compounding quarterly, so these are both 4. Okay, now this value that we get here, N, this is the number of installment periods. It's not a number of years, it's the number of installment periods, as you can see there. Now to turn this into a number of years, we have to know there's 4 installment periods per year. So if we divide this number by 4, we get 2.83. That's the number of years. And we'll turn the 0.83 into months. So 0.83 times 12, 9.96 months. We'll say 10 months. So 2 years, 10 months. And finally, in part D, we've got to work out the sum invested at 8% per annum compound interest if it amounted to $4,000 after 4 years. So P, we don't know. The future amount is going to be 4,000 though, and we know the interest rate is 8%. And we haven't been told anything about compounding periods, so we're going to assume it's 1 per year. Okay, so number of compounding periods, if there's one per year for 4 years, it's just 4. 8%. Present value, we don't know. And the future value is 4,000. And change these to 1. Okay, so the present value must have been 29.40 and 12 cents. Okay, now if we compare our answers for these 4 questions to the answers from question 4, and remembering that in question 2, we're comparing to the answers from question 2, and in question 2 we had the exact same numbers, except that everything was the same except that we were doing flat interest instead of compound interest. Okay, so we have a pretty good comparison here. In part A, we had to work out the amount that would be owing on this amount if it was compounded daily, and we got 115 compounding when we did compound interest compared to 113 when we did flat interest. So the compound interest created a bigger amount of interest, as we would expect. Compound interest creates more. For part B, the fact that we had a lower interest rate here means that, again, compound interest was better than the flat interest rate, because we needed a smaller interest rate for compound interest to achieve the same result as for flat interest, where we needed a bigger interest rate. So with compound, if you've got compound interest, you don't need as big an interest rate to get the same return, because compound interest is better. In part C, the number of years it took to turn $5,000 into $6,000 was less when we compounded compared to when we did flat interest. It took 2 months less to get to the same point using compound interest. And finally, we only needed to invest $2,940 using compound interest, whereas for flat interest, we needed to invest a bit more, about $100 more, in order to get to this amount after 4 years. So in every case, it demonstrates that compound interest, is quicker, generates more money, however you like to put it. It's better than flat interest. Okay, in question 5, a new refrigerator is bought under a hire purchase agreement for this amount of money with a $300 deposit and 24 monthly installments of this to be made. We have to work out the amount of interest charged. Okay, the first bit's pretty easy. If the actual cost, for under the hire purchase agreement was a $300 deposit plus 24 monthly installments of 153, this is going to be the amount we actually pay, and we can compare that to what the upfront cost would have been. So if we put this into a calculator, 300, let's go back to the main screen, 300 plus, we'll put in brackets 24 times 153. So the real total cost was 3,972. And if we take away the upfront cost from that, then we can see 672. That was the extra cost due to the interest we were paying. So that's the amount of interest that we had to pay above and beyond the upfront cost. The amount of interest charged was 672. Okay, for part B we had to work out the flat rate of interest. Okay, flat rate of interest means we're going to use our simple interest equation, I equals PRT over 100. And I was 672. P was the principal. Now the principal debt, this bit can be tricky. The principal was not this amount because right at the very start we paid $300 of the amount off. So we didn't owe $300 at the start. That wasn't our principal. It was $300 minus the deposit. So at the beginning we only owed $3,000. That was the principal. Okay, the flat rate of interest is what we want to work out, and the amount of time over 24 months, that's 2 years. And divide it all by 100. Let's solve that. We'll need the keyboard to make a fraction. Okay, so 672 equals 3000 times R, which we don't know, times the amount of years is 2. It's all over 100, and we want to solve for R, 11.2%. And finally, in part C, we've got to work out the effective rate of interest. Now, if we know the flat rate of interest, it's much easier to use the equation that incorporates flat rate of interest. Okay, so here's one of the equations for the real or effective interest rate, the one that uses flat rate of interest. So all we've got to do is put in 2 times n. N is the number of monthly installments, so 2 times 24 over 24 plus 1 is 25, and then multiply that by 11.2. Okay, so 2 times 24 is 48. Divide that by 25 and we get that, and then multiply that by 11.2, our interest rate. 21.5 is the effective, 21.5% is the real or effective rate of interest. Let's call it REF. Okay, in question 6, Alvin borrows $2,000 from a bank at 14.6% per annum, calculated on a reducing monthly balance with monthly repayments of $40. Now, the fact that it's a reducing monthly balance problem tells us it's going to be very similar to a compound interest problem. Okay, but with one important difference. We've got this these monthly repayments of $40 that we have to include. So we can use our compound interest solver, as we normally would for a compound interest problem. We can put in the interest rate, 14.6%, the present value, that's the initial debt in this case, $2,000, and it says in part A, calculate the amount still owed after the 4th repayment. So 4 payments have been made. If we go to help, you can see that their number of installment periods 4, we've made it. And because these are happening monthly, these installment periods, we have to put down for PY and CY 12. There's 12 installments per year because it's monthly. Okay, once we've put in all that stuff, and actually we also need to put in for the payments, they're negative 40 because they're the negative shows that they're reducing the loan rather than adding on to it. Not making it bigger, it's making it smaller. That's why it's negative. And then when we calculate FV, we get this negative. We can ignore the negative as usual for future value. 1936.18. That's the future value after 4 installments, 4 payments of the original debt. It was 2,000, now it's down to 1936. So 1936 and 18 cents. That's the amount still owed after the 4th repayment. Now you might be a bit surprised that after 4 payments of $40, which adds up to $160 that's been paid back, that the debt's only down to 1936. Okay, that's because after every month, this amount of interest is getting added on to the debt. Okay, so there's interest being charged at the same time as the payments are being made. So there's a little bit going down from the payment, but also a little bit going up because of the interest. So that's why it's not down by 160 as you might expect. Okay, in part B we have to calculate the amount of interest paid in 4 repayments. The amount of interest paid in 4 repayments. Okay, now as we said, the amount of money that's been paid back during those 4 months is $160. So in one way, we might expect the debt to be reduced down to $1840. Okay, but we find that it's actually only down to $1936. So the difference between these two numbers, the amount that the payments should have brought it down to and what it actually is, that's that interest that we were saying just before has been added on to the debt. The 14.6% per annum each month is getting added on to the debt at whatever the balance is at the end of that month. Okay, so the difference between this and that is the interest. So 1936.18 minus 1840, that's going to be the amount of interest that's getting paid here. So let's calculate that on the main screen. So 1936.18 minus 1840 gives us 96.18. That's how much interest has been paid in those 4 repayments. Finally, express the interest paid over the period of 4 months as a percentage of the total payments. The interest paid over the period of 4 months was 96.18. We just worked that out. We've got to express that as a percentage of the total payments. So it's going to be that amount divided by the total payments, which were 160, which we'll put into the calculator here. So 96.18 divided by 160 gives that. If we multiply that by 100, we get a percentage, 60.12. Sorry, 60.11. That's the amount of interest paid as a percentage of the total payments. Okay, let's keep ploughing ahead. So question 7, we've got some machinery bought for this amount and it's expected to have a scrap value of $1,200 after 10 years. Assuming flat rate depreciation, find the yearly depreciation change. Okay, so the first thing we should remember about these kinds of problems, depreciation problems, is that the book value of an item is its principal minus the depreciation. Okay, that's very simple. Its current value is what it was worth minus what it's lost in value. So we know that it was worth $29,600 and we know that it's now worth $1,200. So we should be able to work out D from that equation. If we put it into a solve function, solve 1,200 equals 29,600 minus D, we get 28,400 for D. Okay, and we're assuming flat rate depreciation, so we're assuming that D equals PRT over 100 is true for this problem, and we want to find the yearly depreciation change. Okay, so the amount that happens each year. Now we've just found out that D is 28,400, so we can substitute that in. We know the principal was 29,600, and first we need to work out the interest rate here. So this depreciation occurred over 10 years, so we're going to make T 10 years for the moment and then put it over 100. Okay, so if we solve for 28,400 equals, and then we're going to put in a calculator, we're going to use the keyboard function to put in a fraction. 29,600 times R times 10 years over 100, and we want to solve for R. So we get R equals 9.59. That's the flat rate of interest, flat rate of depreciation for this machine. Okay, now if we want to find the yearly depreciation, now we can use this interest rate to do that. So we want to find the depreciation in 1 year, where the principal's 29,600, the interest rate's 9.59, and the number of years is 1. Okay, we're only looking for the depreciation in 1 year. So we can put all this into the calculator, 29,600. Don't need to use the solve function this time, because we're working out D itself. And we'll put in the answer from the previous line, and the number of years is 1. We need to divide that by 100. Okay, and we've got this funny R thing in here. Let's get rid of that. I think we'll just go back to this equation and put in 9.59 instead of the answer. and then we'll get a straight number. Okay, so we ended up with the yearly depreciation 2838.64. Okay, so that was part A. In part B, we had to find the amount by which depreciation at the end of the second year exceeds the depreciation at the end of the sixth year. Okay, now this is a funny question. I guess it's a trick question, because the depreciation, when it's depreciating by a flat rate, is the same every year. So the depreciation in the second year will be exactly the same as the depreciation in the sixth year. So to ask how much bigger will the depreciation in the second year be, how much does it exceed it by, it won't exceed it at all. The answer is 0. Okay, let's move on to question 8. Alright, in question 8, we've got to find the original cost, which is P, of an item that has a book value, V, of $6,344 after 7 years, if the reducing balance depreciation rate is 18% per annum. So this is reducing balance depreciation. So our equation is going to be book value equals principal 1 minus r over 100 to the power of n. And our book value is 6344. Our principal is what we want to find. We've got 1 minus r is 18 over 100, and the number of years is 7. So we just need to put that into the calculator and solve. 6344 equals P, and in brackets 1 minus, we'll put a little fraction in, 18 over 100, and then put it all to the power of 7. Okay, and we just need to tell the, oh, what's that all about? Looks like we've done too many equations, so I'll copy that and then clear this. We can put it back in. Okay, we want to solve for P, and we need to make sure we put a multiplication symbol in here, and then we get this result. P equals 25,448. and 74 cents. So that was our principal sum or purchase price of this item. Okay, and finally, we've got a photocopier that's purchased for this amount, and it depreciates at an average rate of this many cents per copy. Okay, now often with these unit cost depreciation problems, we have to calculate the unit cost depreciation by working out how much depreciation has occurred and dividing it by the number of times the machine gets used, or whatever it is gets used. In this case, they've just given it to us, the unit cost depreciation. So straight away we know that 2.1 cents, 2.1 times 10 to the negative 3 cents rather, of depreciation occurs every copy that gets made. And in part A we need to work out how much the book value of the photocopier after this many copies are made. So if we multiply this number of copies made by this amount of depreciation per copy, then the this is the per copy, and the copies will cancel out, and we'll just be left with an amount of money, which is what we want. So let's do 2.1 times 10 to the negative 3 cents and multiply that by, cents per copy, and multiply that by 4 times 10 to the power of 8 copies. The copies will cancel out, we'll get our answer in cents. Let's put that into the calculator. So 2.1 times 10 to the power of negative 3, and then we need to multiply that by 4 times 10 to the power of 8. Okay, and we get 840,000 cents. 840,000 cents. Now if we convert that to dollars just by getting rid of 2 of the zeros, we get this amount of depreciation. So the book value, V, is going to equal the purchase price minus the depreciation. It was 11,400 originally, it's lost 8,400, so it's now worth $3,000. Okay, and then in part B we had to work out after how many copies will the photocopier be written off, that is have zero scrap value. So in that case, we're saying in this equation V equals P minus D, the scrap value, or the current value, is 0. The purchase price is 11,400 still, and we want to know how much depreciation occurred. Well, obviously it must have been $11,400 worth of depreciation occurred. Okay, and then we can go back to our equation UCD, unit cost depreciation, equals depreciation divided by the number of copies that are made, or the number of times the machine's used. And we know that UCD was 2.1 times 10 to the negative 3, and we know that depreciation by the end of its life is 11,400. So we just need to calculate N, the number of copies. Let's do a solve. So we've got 2.1 times 10 to the negative 3, and that equals a fraction with 11,400 on top, and on the bottom is N, our unknown. We're solving for N, comma N, and we get N equals, whoa, huge number. So we've got 5,428, 571 copies. That is a number of copies that get made in order to reduce the machine down to a value of 0. But in fact, because this was in cents and this was in dollars, we have a little units problem. So let's convert, say, this one into cents by adding on a couple more zeros, and then we'll recalculate it. So we'll go back into our equation here and add on 2 more zeros there. Now that number is in cents instead of dollars, and we find that we end up with 142 on the end of our number. We get an extra 2 numbers on the end, so it's quite a huge number of copies.